Hello everyone, myself Dr. Santamay Kundu. I welcome you all to this lecture of soft computing techniques. This is the fifth lecture of module 3. So, till now we have covered module 1 and module 2. In module 3, we have studied fuzzy inference systems with examples. So basically, there are three fuzzy inference systems we are studying. One is that Mamdani fuzzy inference system. Second one is that Sugano fuzzy inference system, and third one is that Sukamoto fuzzy inference system. We have solved few examples. Now we'll discuss another example. So please try to understand the next example. So example is that assume we want to evaluate the health of a person based on his height and weight. The input variables are the Cripps numbers of the person's height and weight. In output, we will get the percentage of healthiness. Fuzzification is the process by which the number are changes into linguistic words. So try to understand that the here fuzzy sets are very slim. So fuzzy sets are very slim. So if it is the creep sets, then we may say that from 0 to suppose 50, 45 kg, suppose that less than that, these are the very slim. So that boundary is rigid for the creep sets. For the creep sets, boundaries are for the creep sets, boundaries are very rigid. But here the in fuzzy bounded are flexible. So that's why these things you discussed in the first class. So that's the fuzzification of weight is that suppose weight is less than 52, so that is somehow it is the very slim and between slim. So it may be very slim, it may be slim. So suppose weight is suppose it is 74 or suppose it is 105. So this may be medium. Somehow it may be slim, it may be heavy. So there are boundary are very flexible for the case of fuzzy sets. You know that. For the case of weight, we have discussed the fuzzification. Now fuzzification for the case of height. So if it is height is 140 42 centimeter assume, so that is something like very short, then after that it becomes surely very short. For the case of suppose it is 130 or suppose it is 135 centimeter, height is very short like that. So and from suppose it is 200 centimeter, 202 centimeter, then it also increasing after 205 centimeter, it is surely very tall. So these are the fuzzification of weight and height. Now here the rules are given in the table next slide. So rules are that healthy, so H, somewhat healthy, SH, less healthy, LH, unhealthy, U. The rule function F equal to U, LH, SH and H. So this is the sum parameter in health index parameter, and that is the 1. So that is unhealthy from 0 to 0.4 and 0.2 to 0.4, less healthy, somewhat healthy and healthy. So here rules are that H. So rule 1 you can say that rule R1 is that if height is very short, if height is very short and weight is very slim, weight is very slim, then person is healthy. So that is rule H1. For rule R2, if height is very short and weight is slim, then it is somehow healthy. Here the rule, if height is very short and weight is very heavy, then it is unhealthy. So there are set of rules. You can say there are 25 rules. So I hope you have understood the rule table. Now, for a given person, compute the membership of the person weight and height. Assume the person height is 180 centimeter. So here somehow it is 180 centimeter. So if you say, you will get the tall is 0.3 and the medium is 0.7. So the membership function of medium is 0.7, membership function of tall is 0.3, rest as 0 for the case of the 185 centimeter. Now the person weight is 49 kg. So 49 kg here. So 0.2 it is slim. So slim membership value of slim is 0.2 and this is for very slim, so that is 0.8. Rest as are 0. So these are the input. These are the membership functions based on the input of these numbers. Now the so here 0.8, this is belongs to the weight. So weight is here very slim, and you check here for the case of very slim 0.8, for the case of slim 0.2. So for the case this is 0.8 for very slim, this is very slim, and this is basically the slim for the case of weight. Now for the case of height, this is the medium, this is belongs to 0.7. For the case of weight, 0.7 belongs to the medium and it is tall is 0.3. So now rule is that for if the so rule says that if weight, the rule says that if height is medium, if height is medium and weight is very slim and weight is very slim, then less healthy. So this is become the less healthy. This is become healthy. So the less healthy value is 0.7. The minimum of these two 0.7 and 0.8. Here the minimum of 0.7 and 0.2 is 0.2. So that is healthy. For unhealthy, that is 0.3, minimum value of 0.8 and 0.3, and minimum value of 0.3 and 0.2 is 0.2. So as a output, we got the value for less healthy, value is 0.7, minimum of 0.8 and 0.7, value of healthy, that is the minimum of 0.7 and 0.2 is 0.2, unhealthy minimum of 0.8, 0.3 is 0.3, and somehow healthy, that is 0.2 and 0.3, so minimum is 0.2. So these are the output. The next step is defudgification. So for defudgification, we are using weighted average method, as here all consequent or output fuzzy sets are symmetrical. In this method, the defudgified value is summation of xi into mu ai xi divided by mu ai xi. So in this method, the value of healthiness parameter equal to 0.2 into 0.3 plus 0.4 into 0.7 plus 0.6 into 0.2 plus 0.8 into 0.2. So divided by 0.3 plus 0.7 plus 0.2 plus 0.2. So that is 0.06 plus 0.28 plus 0.12 plus 0.16 divided by 1.4. So that is 0.62 by 1.4, that is 0.44. So here the defagified value is 0.44. The value 0.44 here lies in the region of less healthy and somewhat healthy. For less healthy, points are 0.41, 0.60. So y minus 0 is equal to, if I find the equation of this line, so that is y minus 0 equal to 1 minus 0, 0.4 minus 0.6, x minus 0.6. So that is y equal to 1 by minus 0.2 into x minus 0.6. So that is 5 into 0.6 minus x. Here given x is 0.44. So you need to put the x value here. So y equal to 5 into 0.6 minus 0.44. So that is 5 into 0.16 and we got 0.80. Similarly, for somewhat healthy, points are 0.40 and 0.61. So the equation of this line is y minus 0, 1 minus 0, 0.6 minus 0.4, x minus 0.4. So that is y equal to 1 by 0.2, x minus 0.4, or y equal to 5 into x minus 0.4. For x equal to 0.44, y is equal to 5 into 0.44 minus 0.4, that is 5 into 0.04 or 0.20. So we can say that the person whose height is 185 centimeter and weight is 49 kg is 80% less healthy and 20% somewhat healthy. Question is that by measuring your own height and weight, calculate your healthiness parameter. So we have discussed the fuzzy inference systems, that is Mamdani, Sugenu, Sukamoto method. So we have seen that the steps are there input, so there we input the Cripps numbers. Then at the given fuzzy set, we are getting the membership function here. We are obtaining membership functions. Then we are applying the rule, fuzzy rule, if and or maxima. So we apply the rules and also apply the rules with fuzzy inference system. With inference system, then after defuzzification we are getting the output. So these steps, fuzzified rules with inference system, defuzzification, is known as the fuzzy knowledge base. So Mamdani fuzzy interface. So the Mamdani style fuzzy inference, Mamdani fuzzy inference. The Mamdani style fuzzy inference process is performed in 4 steps. I have seen it. The fuzzification of the input variable, rule evaluation, aggregation of the rules output, and finally defuzzifications. So these are the Mamdani fuzzy inference system. So Cripps input, then membership value, then rule, then fuzzy output, then aggregate, then fuzzy. After defuzzification, we are getting the Cripps output. So that is basically one the model. So it's similar model for Sugenu, for Sukamoto. Little bit different the rule system or the output fuzzy sets. So for the case of Sugeno, you can check this is basically the Cripps output here. So similarly, all these things are there. So in Sugeno fuzzy model, that is also known as the TSK fuzzy model based on Takagai, Sugeno and Kang 1985. Here the goal is generation of fuzzy rules from a given input-output dataset. Mamdani style inference requires to find the centroid of a two-dimensional shape. You have understood these things. So by integrating across a continuously varying function, So in general, this process is not computationally efficient. Whereas Suganu suggested to use a single spike, that is singleton, as the membership function of the rule consequent. A fuzzy singleton, that is a fuzzy set with a membership function that is unity at single particular point of the universe of discourse and zero everywhere else. So this is the basically the you can say a fuzzy singleton. So that is x, this is mu x, this is value is 1. This value is 1. So Sugano style fuzzy inference is very similar to Mamdani method. Sugano changed only a rule consequent. Instead of fuzzy set, he used a mathematical function of the input variable like z equal to p1 pix plus qy plus ri. So z equal to pix plus qy plus ri. So we get here z equal to pix plus qy plus ri. Similarly, here the defuzzified, here the output value is z star equal to, it is w1 z1 plus w2 z2 plus wn zn plus z1 plus z2 and so on. So in this way we got the value. So Sukamoto fuzzy method, the consequent of each fuzzy if then rule. So a fuzzy set with the monotonical membership functions. So overall output, the weighted average of each rule output. So here you know the Sugano output is either increasing or output is either decreasing. So that is the one rule for Sukamoto fuzzy model. So here is that so all the rules, that is Mamdani fuzzy model, Sugano fuzzy models, and Sukamoto fuzzy model, their antecedent parts are almost same because all rules are antecedent part. That is, if rule Ri, so it says that if x is ai and y is bi. So rule part is same for all the three Mamdani, Sugano, and Sukamoto. But here the different style in consequence. Consequence for Mamdani, it is says like ZI, then Mamdani says that, then in Mamdani it is said that, then Z is CI, where CI is a fuzzy set. In Sugano, that is in Mamdani, in Sugano it is said then ZI is, then ZI is PIX plus QIY plus Ri. In Sukamoto, it is also the monotonic membership function. Monotonical membership function. So in output, in consequent part, the style is different, whereas in the style is same for the antecedents part. So how to make a decision on fuzzy method to apply Mamdani or Sugano? So Mamdani method is widely accepted for capturing expert knowledge. It allows us to describe the expertise in human-like manner. Sugano method is computationally effective and works well with optimization and adaptive techniques, which makes it very attractive in control problems, particularly for dynamic nonlinear systems. So in this class, we have understood the fuzzy inference systems. So there are different steps in the designing fuzzy system. So first one is that you need to identify the system input variables, their ranges and membership functions. Identify the output variables, their ranges and membership functions. Identify the rules that describe the relations of the input to the outputs. Last one is that determine the defuzzifier method of combining fuzzy rules into the system outputs. So these are the steps. First, we need to input, then convert it to the uh, fuzzification step. So first one is the input, then by using fuzzification step, calculate membership functions. We'll get fuzzy inputs, then apply the rules, we'll get a fuzzy output, combine all the outputs, then apply defuzzification step, calculate a Krebs value, so that is the output. So this is the fuzzy inference systems. So now, the question for today's class is that, question is that, we apply uh, some fuzzy sets, like apply any fuzzy sets, apply, or question is that, develop Sugeno, Sukamoto, of. So consider any proper example and try to develop Mamdani, Sugeno. So these are, thank you.